Welcome to this explainer. Look, today we're going to fundamentally shift how you approach B2B procurement and total project costs. If you're an EPC contractor or procurement manager, you already know that sourcing industrial components from overseas can be, well, incredibly complex, right? But today, we're taking a really fascinating look at the data and insights from the 2026 Buyer Fit Ranking for China's cable tray manufacturers. We're going to unpack exactly what goes wrong when buying these absolutely critical systems, and more importantly, how you can actually get it right.
Okay, so here's our roadmap for this explainer. We'll quickly cover 1. The unit price trap. 2. Standards, the power plug analogy. 3. Top sourcing pitfalls. 4. The buyer fit criteria. And finally, number 5, verifying your supplier. Let's get into it.
Section 1, the unit price trap. We're starting off with the most common, yet literally the most dangerous, illusion in EPC procurement today. I really want you to ask yourself this critical question before you ever make a selection from a supplier directory page again. It is incredibly tempting, isn't it? You look at a giant spreadsheet of quotes, you spot the lowest number for a meter of cable tray, and you just want to award the contract. But the source material explicitly warns us that choosing a manufacturer purely based on a directory page listing is just fundamentally different from identifying the right, truly capable supplier for a complex, high-stakes project.
And honestly, this brilliantly illustrates the whole iceberg reality of global procurement. What looks like a super cheap unit price up front, that tiny tip of the iceberg, absolutely skyrockets when you factor in the massive hidden costs lurking just below the surface. When you just look at the unit price, you're entirely ignoring the total package cost. And that total package cost, it accounts for the disastrous realities of specification mismatches, the sudden, terrifying realization that crucial mounting accessories are totally missing, and the subsequent site delays that will just bleed your project's budget dry.
Section 2, Standards, the power plug analogy. Let's look at how international engineering standards actually interact with domestic manufacturing realities.
Okay, to really understand this, think of international standards like IEC 61537 or NEMA VE1 as your specific electronic device's power plug. Now, think of the domestic Chinese production standards, which are known as GB standards, like GB 31251, as the local wall socket in a foreign country. If a manufacturer lacks the engineering adapter to perfectly translate those international specs into their domestic manufacturing process, what happens? Well, they try to force it to fit. And just like jamming a foreign plug into the wrong socket, it causes a total systemic failure and ends up burning down your project timeline.
Section 3, Top sourcing pitfalls. Let's see how that specification friction builds directly into the specific hazards that you absolutely must navigate around. We're focusing heavily on identifying these traps before you fall into them.
So the crucial point here is that everything boils down to this single monumental risk factor that ruins more projects than literally anything else. And spoiler alert, it isn't shipping delays and it isn't raw material costs.
These are the specific pitfalls that act as that submerged ice ready to sink your project. Number 1 is that specification mismatch we just discussed. The supplier says they can meet NEMA standards, but they actually manufacture to local GB tolerances, meaning the part simply won't pass your site engineer's inspection. No way. Number 2 is missing accessories. Guys, it is never just the tray. It's the splice plates, the hold-down clamps, the seismic bracing. A supplier quoting just the straight metal tray while ignoring the integration hardware is 100% setting you up for failure. And number 3 is just the inevitable result of the first two, catastrophic site delays.
Section 4, the buyer fit criteria. To avoid those pitfalls, we need a way better evaluation methodology designed specifically for EPC teams. The data reveals these 5 core buyer fit criteria that construct a reliable, risk-averse supplier profile. And notably, this is interesting, basic market share and gross revenue are completely excluded from this formula. Why? Because a company pumping out millions of meters of commercial-grade tray for local apartments might have massive revenue, sure, but they will completely fail to meet the rigorous IEC standards required for an international data center or a rail transit project. You need a targeted fit, not just a massive factory.
Think of the data here as your ultimate cheat sheet. It breaks down exactly which of the top 10 manufacturers fit your specific project type and precisely what you got to verify before placing an order. Instead of blindly sending out requests for quotes to everyone on a directory, you actually match your project, say an industrial plant, with a supplier whose proven engineering capabilities actually align with those specific rigorous demands.
Section 5, verifying your supplier.
Finally, we're going to translate all of this theory into tangible, boots-on-the-ground steps that you have to take to secure your project.
We've distilled the comprehensive 10-point supplier verification checklist from the source down into these absolute critical steps that EPC teams must execute before ever granting technical approval. You must proactively verify their standards compliance. You must demand an itemized list of all accessories. Seriously, do not assume anything is included unless it is explicitly written down on paper. By doing this up front, you ensure that the adapter between what you need and what they actually make exists. For instance, looking at a manufacturer like Zenema demonstrates how a supplier properly builds that engineering adapter we talked about earlier. They explicitly manufacture cable trace systems, busway, and seismic bracing that seamlessly bridge international standards like BS EN 50085 with domestic GB 31251. And this is exactly the kind of verifiable, multi-standard compliance you need to look for when you're outfitting complex data centers or industrial facilities.
I really want to make sure this singular, vital takeaway from the source material is front and center for your next procurement cycle. If you remember only one thing from this entire explainer, let it be this. Specification mismatch will cost you exponentially more than whatever money you thought you saved on a low unit price up front.
As we wrap up, I'll leave you to ponder this pretty provocative question. When you look at that lowest quote sitting on your desk right now, are you really just buying metal, or are you accidentally purchasing a catastrophic project delay? The difference entirely comes down to your verification process. Take these frameworks, demand exact standard matching, and verify absolutely everything before you order. Thanks for joining me on this explainer, and stay curious.